Apple did not just change laptops. It changed where the computer happens. That sounds dramatic, but it is the cleanest way to understand Apple Silicon. The M series was not only a faster chip, it was a different layout for the whole machine. CPU, graphics, memory, security, video engines, and machine learning stopped behaving like separate islands. They became one tightly designed system, and that is why the laptop suddenly felt quieter, cooler, and harder to compare. Before the shift, most laptops followed a familiar pattern. The processor did one job, graphics did another, and memory sat off to the side. When an app needed to edit video, draw a screen, encrypt a file, or run an AI task, data kept moving around. Some of that movement was useful. A lot of it was just bookkeeping. Copy this, wait there, cool that, feed the next ship. Moving data costs time. More importantly for a laptop, it costs power. And power turns into heat, which turns into fan noise, throttling, bigger batteries, and thicker machines. That is the old laptop bargain. You could have portability, battery life, or high performance, but getting all three was difficult. The M series attacked that bargain by borrowing a phone idea and scaling it up. In a phone, the whole device lives under extreme limits. Tiny battery, tiny body, no room for waste. Apple had spent years designing chips for that world. Then it moved the same philosophy into the Mac. The first M1 chip put a huge amount of the computer onto one package. Apple described it as the first chip designed specifically for the Mac, using a system-on-a-chip design and unified memory. That matters because integration is not just a neat engineering detail. It changes the path that work takes. Instead of a laptop constantly handing data from one neighborhood to another, more of the work happens in one planned city. The CPU can run ordinary code. The graphics cores can draw and compute. The media engines can handle video streams. The neural engine can accelerate machine learning tasks. The secure enclave can protect sensitive keys and identity data. The important part is not that every block exists. It is that Apple designs the blocks, the operating system, and the hardware around each other. That is the Apple Silicon trick. Less generic flexibility, more controlled efficiency. Unified memory is the piece most people hear about, but it is easy to misunderstand. It does not mean the laptop magically has infinite memory. It means the main parts of the chip share one high-speed memory pool. On many older designs, the CPU had its memory and the graphics side had to be fed separately. If the graphics side needed the same image, frame, or model data, the system often had to copy it across boundaries. Apple's approach lets different engines reach the same data with less duplication. For video editing, photo work, app switching, and local AI, that could be a big deal. You're not only waiting for math. You're waiting for memory traffic, compression, decompression, and copies. When those copies shrink, a thin laptop can feel much bigger than it looks. This is why raw benchmark charts never told the whole story. The surprise was not only that M1 was fast. The surprise was that it stayed fast while sipping power. A fanless MacBook Air could suddenly do work that used to make small laptops sound like tiny jet engines. That changed what buyers expected. A laptop was no longer allowed to become useless the moment it left the charger. It also changed what silence meant. No fan noise was not a luxury feature. It was proof that wasted power had been cut. The deeper win was performance per watt. How much useful work the machine does for each unit of energy. Desktop chips can brute force a problem by burning more power. Laptops cannot get away with that for long. Apple Silicon made the laptop conversation less about peak speed and more about sustained speed on battery. Then Apple kept stacking specialized engines around the general-purpose cores. The media engines matter because video is one of the heaviest everyday tasks people actually do. If a dedicated block can decode or encode video efficiently, the main processor does not have to sweat over every frame. That is why a small laptop can edit, preview, or export footage while still feeling calm. The neural engine is the same idea applied to machine learning. It is not a replacement for every AI workload, but it gives the device a local lane for the tasks that fit. By the M4 generation, Apple was talking about tens of trillions of operations per second for its neural engine. That connects directly to what is happening now. AI is moving from distant data centers onto personal devices. The cloud still matters. Big models, huge context windows, and heavy training still need serious infrastructure. But every task that can run locally changes the economics. Less waiting, less data leaving the device, and less server work for small requests. That is why Apple Silicon is not only a Mac story. It is part of the on-device AI story. And the rest of the laptop market noticed. Microsoft later introduced Copilot Plus PCs. Around the same broad idea, CPU, graphics, and a dedicated NPU working together for local AI features. Qualcomm, AMD, Intel, and others all push harder on efficient laptop silicon and neural processors. That does not mean Apple is unbeatable. It means Apple forced the question everyone else had to answer. Can a laptop feel fast, quiet, and intelligent while it's unplugged? For you, the buyer, the lesson starts with a better question. Not how fast is the chip, but how well does the whole machine work together? That means looking at memory, media, graphics, AI, security, heat, battery, and the software around them. A laptop is no longer just a CPU with a screen attached. It is a system of specialized engines, and integration determines how efficiently they cooperate. Apple's big move was designing those engines as one product. That creates the performance per watt advantage, but it also creates the trade-offs. The tighter the integration, the less energy the machine wastes. But the same tight design can also reduce what you can change later. So the Apple Silicon story is not simply that one company made a faster chip. It is a set of engineering choices, shared memory instead of separate pools, specialized engines instead of brute force, and control instead of flexibility. Those choices explain both the remarkable battery life and the compromises buyers need to understand. The first consequence is upgradability. Unified memory is fast because it is tightly packaged, but you choose the amount when you buy. That makes the machine efficient, but it also makes the memory decision more permanent than old removable laptop RAM. So if you plan to keep a laptop for years, memory is not just a spec line. It is headroom. The second trade-off is compatibility. Moving from x86 chips to Apple Silicon, many apps had to become native or run through translation. Apple made that transition smoother because it controlled the hardware, the operating system, the developer tools, and the App Store pressure. The Windows world is harder. It has more chip vendors, more PC makers, more old software, and more strange hardware combinations. That is one reason the response took time. Copying a chip idea is easier than moving an entire ecosystem. The third trade-off is peak power. A giant workstation GPU can still beat a thin laptop when the job is huge enough. But Apple changed the default question. Most people are not rendering a Hollywood film all day. They're doing bursts of mixed work. Browse, call, edit, export, unlock, search photos, summarize text, play video, sleep, wake, and do it again on battery. For that kind of real laptop life, a balanced system can beat a hotter collection of separate parts. That is the buyer checklist now. Memory headroom, battery while unplugged, media engines, neural processing, heat, and long-term software support. The point is not that everyone should buy Apple. The point is that Apple changed what every good laptop has to prove. Fast is no longer enough. Fast, quiet, private, efficient, and local is the new target. That is why the M series still matters as AI moves onto personal devices. It was not just a better Mac chip. It was a preview of the next personal computer. That is tech, finally explained. This is Tech It Away, and I will see you in the next one.